Hey everyone, it's Miss Lloyd, and today we are looking at linear inequalities with one variable. So typically, whenever we're working with inequalities, we have a certain way that we like to show our solutions. And so these are intervals, it's a type of notation to represent those solutions. And so we have two different types, either bounded or unbounded. So bounded means that we're in between these two numbers. Unbounded means between where we start at one number and we're either greater than that for forever or less than that for forever. And we also want to pay attention to the square brackets versus the parentheses. So the brackets are used to show an equal, so it's greater than or equal to, so we're including that number. And then the parentheses just means that we're around that number, but we're not including that exact number. And we can have a variety. So we can have some that have both square brackets and the parentheses. And then same thing over here, we can't touch infinity, so the infinity symbols, whether they're positive or negative, are always going to have those parentheses. And then our numbers that we're starting at, those can either have parentheses or brackets depending on if it's an equal to sign or not. So for this first example, just writing the inequality as an interval and stating whether it's bounded or unbounded. So I know the number that I'm using is negative 16, so I'm going to represent that. And it's saying that x is less than or equal to negative 16. So that less than sign means that I'm going from negative 16 and I'm going all the way to the left, as far left as I can go. These are all of my negative numbers, so that I know that I'm going all the way to negative infinity. And when we're doing these intervals, we always want to order least to greatest. Negative infinity is the smallest number you could possibly have, so that's what we're going to start with. I know that I have to have a curved bracket or a parenthesis when it comes to the negative infinity. They always have the curves. And because we have an or equal to sign here, that means I'm going to have a bracket, a square bracket, around my negative 16. So this is showing me negative infinity to negative 16, so x is less than or equal to negative 16. And because I have this infinity symbol, this means that I'm unbounded. So properties of inequalities, they're very similar to what my students would have seen in the past, so that's not something I'm really going to go over. If they need a refresher, there's a page number in our textbook to kind of quickly go over that. I'm just going to get right into it. So when we're solving our inequalities, I want to get one of my variables or all of my variables over to one side, same way we would if we had an equal sign. I like to have positive because when we have inequalities, we do have to worry about dividing by a negative. When we divide by a negative, we have to flip that inequality sign. It's one of the biggest differences between an equality or an equal equation and an inequality. So here when I'm dividing, it's a positive 2, so I don't have to worry about flipping any signs. And typically when we write our final solution, our variable comes first. And we can see I call this an alligator. The alligator is opening towards the x. It wants to eat the x, so it's going to keep opening towards the x whenever I flip my sign or flip my inequality so that the x comes first. And so a way that we would write that in interval form, because x is greater than negative 5, that means negative 5 is the smallest. It's not including negative 5, there's no or equal to sign. And because it's greater than, it's going all the way to the positive infinity, which again doesn't get a square bracket. My next big, so say we have double inequalities. We don't just have one, maybe there are two inequalities in the same situation. The first thing, there's two options. One is to separate and solve them as if they were two different inequalities. So you can see that below in the example B. It's technically a double inequality because we're looking at two at the same time, but they are separate. They are two completely different inequalities. So you can do the same thing if they showed up together in one big line. And then you would just solve as if they were different. Option 2, I like this way a little bit more because it's a little bit quicker and I'm kind of lazy. So we're going to isolate the variable in the middle. As we move everything over or try to get everything out of the middle, what we do to one side, we have to do to all of them. So by side, what I do first is I just kind of like make a little border here. So I have three sides to my inequality. and they go along those inequalities. So first, if I'm trying to get rid of the stuff in the middle to get the x alone, I would move the 7. But what I do to 1, I have to do to every single side. So everyone gets a -7. Now I have to get rid of the 2. So when I divide by my 2, again, I have to divide everything by that 2. So now this wanted me to also graph. So in my little line here, I'm going to have -3 is the smallest, 2 is larger than that. Some use the brackets to show their graphs. I use bubbles because I think it makes a little bit more sense. It's easier to see. Sometimes if I'm in the line and I have a square bracket versus a parenthesis, depending on your handwriting, they can look very close, very similar. So I think it's a little bit easier if we use bubbles above, and then you don't have to worry about your handwriting and if it looks like a square bracket versus a parenthesis. So here we have open bubbles because they're not or equal to. So if you don't have an or equal to sign, they're going to be open. And then x is in the middle here, so x is technically greater than -3, so that means it's going to the right. X is also less than the +2, which means that would be going to the left. So these numbers here all satisfy everything that has to do with this. Any of these numbers in between. So anything bigger than -3 and anything smaller than 2, if you plug it in, it'll work out. When we are solving inequalities with absolute value symbols, first thing we want to do is isolate the absolute value. If it's not already alone, so we can see in B that I'm going to be using with my students, there's a -5 on the left side, so we would want to move that first and get that absolute value alone. Once we do that, we want to create 2 different inequalities. And so here's kind of like the wordy version. This is the best that I could do in writing this down in words. I think it makes more sense, at least to me, because I'm a visual person. It makes more sense to me if I just kind of write it out and explain it than if I try to write it down in words. So over here, my absolute value symbol is already isolated. So I'm going to have my first inequality. And it's basically going to be the same thing that's already there, just without the absolute value symbols. So that's my inequality number 1. When I make this second inequality, I'm going to have everything the same. So my x minus 20, except for the stuff on the other side. So basically what I'm saying is that with absolute values, anything that's inside, if it's positive, it's going to remain the same. If it's negative, then the sign changes to positive because we're talking about distance. So then in order to represent the changing of the sign from negative to positive, I'm basically multiplying one side by -1. Because I'm multiplying by -1, the inequality sign has to change, and that now becomes a -4. So that second inequality is a little bit tricky. It's a little bit different because we're representing that change from a negative to a positive value. So then for the rest of this, we can kind of just move on as is. So I can add my 20 to solve for my x. And so I have x is less than or equal to 24. I can do the same to the other side. So my x is greater than or equal to a +16. So whenever I plug this into my final answer, I'm going to do least to greatest. So 16 is less than or equal to, because we're opening up towards the x. And then x is less than or equal to 24. So when I'm graphing, those are the 2 numbers that I'm going to have on my graph. 16 is smaller, it goes first, and then 24. We have the or equal to symbol, so these are going to be filled in bubbles, so it means we're including these numbers. And then x is greater than 16, that's going to the right, less than 24, going to the left, so all of these points in between would satisfy the situation. And then the last one that I'm going to go over online, here it says to use a calculator, and we can use a calculator, that's fine. I'm going to show my students how to do this in the calculator. I don't have a calculator app that I can readily use right now, so I'm just going to do this freehand, and hopefully it is helpful. So we're going to graph all 3 of these. So we've got an equation and 2 inequalities. I'm going to graph my equation first, starting at +1 for my y-intercept. And I'm going up 2, and to the right 3 for my positive slope. Same as going down 2 and to the left 3. Hopefully my line agrees with me. Kind of does. I just need to change that. That looks about better anyway. Now my next one, this is a Y line, so our Y is going to be horizontal. And a horizontal line at 5. And it also says Y is less than or equal to 5, meaning that I'm looking at everything that is smaller than 5, and everything that's smaller than Y is 5 is going down. Next, I'm looking at the Y is equal to 0, and so 0 is at the origin, and again, Y is horizontal, so I'm basically just looking at the x-axis. And it's saying that Y is greater than that, so we're looking at numbers that are bigger, so above. So here it wants me to find values of x that satisfy each of these inequalities, so all of them at the same time. So I'm looking at where I have the red and the green and the orange all kind of muddling together at the same time. And so that's starting here at this point and ending here at this point. So my lowest x value where I have green and orange and red all at the same time is going to be at -1. And then my last point where I have all 3 at the same time looks like it's at +6. And we were looking at x values where my x is +6. So, and it's all the places in between. So we're looking at numbers that are greater than -1 and numbers that are smaller than 6. And so these would have square brackets. And so that's all that I have for you guys today. If you found it helpful, please like and subscribe. And if you think that someone else would find this beneficial, then please feel free to share it with them. Spread the love.